Hi students, welcome back. Let's continue with the classifications of routing protocols in ad hoc networks. Now let's see this another example in the reactive routing protocols. So far we had seen some proactive protocols. In the previous video I explained about one of the example of reacting. Let's see another example in reactive routing protocols. That is ad hoc on-demand distance vector routing protocols. We call it as AODV. A is ad hoc or on-demand distance vector routing protocols. So which you call it as a reactive routing protocol. It is a reactive routing protocol. So here just like the reactive means itself the routes are created when needed. That's why we call it as on-demand. Routes are created when demand. The ad hoc on-demand distance vector routing protocol is having route discovery and the route maintenance. So it's having route discovery as well as route maintenance. So whatever the protocol that you are taken, so first it has to discover the route and it has to maintain the routes. But the each protocol will have their own way of style to transfer the data and to receive the data. So the route discovery and route maintenance. Here the route discovery, the route request will be there and the route reply will be there. The route discovery consisting of route request. So first it is requesting for the route. Which direction is the best direction? After discovering the route, it has to reply. Okay, the way that it comes, the shortest path, that is the best path. So just send the data on that. Like that, it just reply. The route request can be done through broadcast. So the route request means it is the source is going to send the data to all the neighboring nodes. So again these neighboring nodes will send to the other nodes which are neighbor to this node. So like this it is broadcasting. The message is broadcasting here. So the route request is also always follows the broadcasting, whereas a route reply is a unicast. Why it is using the unicast? Because once the destination reaches the shortest distance, rather than broadcasting, it's just reply only to that shortest path. Only to the selected shortest path. So that's why always the route reply is a unicast and the route reply is a unicast and route request is a broadcast. So this will these two will be work on the route discovery. So route maintenance, the route reply request. Route reply request. Okay, it means here any error is there, that will be going to be maintained by route maintenance. So when a node wishes to send a packet to some destination, first it has to check the routing table. So if route exists, forward to next hop. If suppose the route is not exist, it initiates the route discovery. So this is exactly the process what this ad hoc on-demand distance vector routing protocol will do. So it has to discover the route and after discovering the route, it has to maintain the route. So the first step is the source has to request. It has to check the destination path, actually where the destination was, at which place the destination is there. So first it sends the route request packet to all the neighboring nodes. So in what way it sends the information to the neighboring nodes? So the route request packet in ad hoc on-demand distance vector carries the, let me show you. So in what way? Route request. So it sends the information to all the neighboring nodes, like the source ID means this source ID and the destination ID means to where it has to send the packet, and it consisting of source sequence number. So here it is source and next another, the sequence number of the source will be changing, means so it has to give the source sequence number as well as the destination sequence number, and you need to give the broadcast ID also, broadcast ID. So this broadcast ID use it to discard the multiple copies. Why we are using the broadcast ID in ad hoc? So whatever the example, the previous you are taken the reactive, there only the source ID, destination ID you are taking. But here in ad hoc, on demand, you need to take the broadcast ID also. The broadcast ID use it to discard the multiple copies of same root request. So it's just discarding the multiple copies of same root request. And we will use the TTL also. TTL is nothing but time to leave, which is used to allow loops. So this is the information that the root request is sending to all the neighboring nodes of the source. So let's see the working procedure. The ad hoc on-demand distance vector routing protocol performs as follows. When a node does not have a valid route to destination, let us take which is the node, whatever it is sending the data, that the node does not have a valid route to destination, a root request is forwarded. Okay, this is the source. The source is sending the information to some neighboring nodes. Okay. Suppose here this node does not have a valid route. Let us take this does not have a valid route. So then it sends a root request to forward the packet. Root request is forwarded. So it is asking which route is the best route. So please suggest me. When intermediate node receives a root request packet, so let us take this is an intermediate node. So this intermediate node receives a root request packet to two cases are possible. So what this intermediate node can do? It can, if it does not have a valid route to destination, the node forwarded to it. Suppose for this also it does not have any valid route to destination, just it has the another node. It just asks the another node in the network to search for the valid route. Means just forwarding the packet. What packet? Root request packet is forwarding. Suppose if it has a valid route, let us take the C founds the destination, the exact correct route. Then the node prepares for route reply message. So then this C nodes is ready to is preparing for route reply message, means saying to A, okay, this there is a path for me to transfer the packet to destination. So again this responds to the source by route reply message. Okay, suppose if there is no valid route, it just forward the packet. Route request packet is just forwarding. Whenever you are finding the valid route, just it replies the route reply message by saying a valid path is formed. If the route request is received multiple times, let us take the route request is received multiple times. Means here a route request is coming from B side as well as the C side. A multiple route request is received by this E. The duplicate copies are discarded. Okay. So it just checks which one is the correct one and discards the duplicate copies. Or the duplicate copies are determined comparing broadcast ID and the source ID pairs. So how this E node is identifying which is the correct path, then which node it has to be discarded by checking the broadcast ID and the source ID. So here the source ID is having and the broadcast ID from where it is coming, from C to D, D to E, C, C to A to C, C to E, like that. So just take the shortest path with the help of broadcast ID and the source ID pairs. When route request is forwarded, the address of the previous node, its broadcast or stored, or which are needed to forward the packet to sources. Suppose if route reply is not received, let us take the route reply is not received before a time expires, this entry will be deleted. So when the route reply is sent, so whenever there is a valid route, then you are just giving a message like route reply. The intermediate node is giving the route reply. So suppose if route reply is not received before a time expires, then that entry will be deleted. either destination node or intermediate node responds with a valid route. So whether you are in an intermediate position, node position, or you are at a destination position, you need to give that node, that node has to give response of valid route to the source. When route request is forwarded back, the address of the previous node and its broadcast IDs has to be showed. Okay, so whenever it is going to forward back, it's while forwarding front, we need to save all the nodes, that is a broadcast ID and the previous node information has to stored in the cache. So which are needed to forward the packet to destination. So let's see the simple example. So this is an example here, AODV. So here these are the nodes. Let us take this one, that is a source, sends a data packet to 7. It wants to send the data packet to 7, the source and the destination. So assume 6 knows the current route to the node 7. So you just assume 6 will knows the correct route. So whenever the 6 knows the correct route, then what the 6 will do? 6 will send the reply request packet. Route reply message will be sent to the source. So the node 1 sends a route request packets to all its neighbors. So it's just sending the route request to the neighboring nodes. So again this will be broadcast a route request to the neighboring nodes. Whenever the valid route will be there, it's just reply with the route reply message. Route request. So all the nodes will send a route request packet to its neighbor nodes. So with what information this route request will hold? The route request is having the information like source address, that is a 1, destination address, that is a 7. Broadcast ID should be always incremented, broadcast ID plus 1. So here it will be incremented. This is 1 and 2. Okay, so the broadcast ID of the source is 2. So source sequence number is also incremented, and the destination sequence number is the last destination sequence number for node 7. Whatever that is there, that will be the destination sequence number. So this is about the AODV protocol. Thank you.